Here we are going to walk through a matrix multiplication problem. So first we're going to discuss the dimensions of the matrices, and then we're going to talk about how to find the entries of the product matrix. So the first matrix here is a 2 by 3, 2 rows and 3 columns. And the second one here is a 3 by 2, 3 rows and 2 columns. So as long as these two numbers in the middle are the same, we know we can do the matrix multiplication. And the dimensions of the product matrix are going to be 2 by 2, which means 2 rows and 2 columns. Okay, so how will we get the entries of our product matrix? So I'm going to go ahead and set up a little 2 by 2 right here. So the 2 rows and 2 columns. So we knew that as long as the first matrix had 3 columns and the second matrix had 3 rows, we could do the multiplication. And then we're using the number of rows from the first and the number of columns from the second to go ahead and set up our product matrix. So what this is going to look like is I'm going to go across the rows of the left matrix and down the columns of the right matrix. I'm going to multiply terms and then add the consecutive products. So in this product matrix, I'm going to focus on row 1, column 1. So what entry goes in row 1, column 1? Well, I'm going to go across row 1 and down column 1. So I'm going to take each term in order and multiply them together, and then I'm going to add those consecutive products. So negative 2 times 1, and we're going to add to that 3 times negative 2, and we're going to add to that 1 times 0. So when I simplify this, that's going to be the entry at row 1, column 1. Well, okay, well if we slide over here and do row 1, column 2, what will that look like? Well, I'm still in the first row, so I'm still going to use this first row here. But instead of being in the first column, I'm in the second column, so I'm going to shift over and use this second column. So across the row, down the column. So row 1, column 2 is going to go here in row 1, column 2. So negative 2 times 5. We're going to add to that 3 times 2. We're going to add to that 1 times negative 1. I can go ahead and close that because I know I'm only doing 2 columns because the second matrix only has 2 columns. Okay, so I've gone across the first row, so I'm done with this row. Now I need to find all these terms for the second row, so I'm going to move on to row 2 here. So this entry is row 2, column 1, so I'm going to grab terms from row 2 and column 1. So 0 times 1, and to that I'm going to add 5 times negative 2, and to that I'm going to add 2 times 0. And you'll notice some nice patterns that will start to emerge here. So finally, row 2, column 2, so I'm going to take row 2 and column 2, and I'm going to multiply terms 0 times 5, and to that I'm going to add 5 times 2, and finally add 2 times negative 1. So let's take a second here and look at these patterns that have emerged. So if we look vertically, all these numbers are the same. And if you look horizontally, negative 2, 3, 3, 1, 1, and it's similar to that in the second row as well. So now that I have all my entries set up, now it's just a matter of simplifying. So negative 2 times 1, and then 3 times negative 2, and that guy just zeroes out, so I don't care about him. Let's shift over here, so negative 10 plus 6 minus 1. And let's go down to the second row, so that zeroes out. So negative 10, and then that zeroes out, so just negative 10 is the answer there. So over here, that guy zeroes out, so I'm left with 10 minus 2. And the final answer then is going to be negative 2 minus 6 is negative 8. Negative 10 plus 6 is negative 4. Minus 1 is negative 5. That guy's just negative 10. And then there's an 8 right there. So this 2 by 2 matrix is going to be the product matrix that I get when I multiply this 2 by 3 matrix with this 3 by 2 matrix.